Hi, I'm Matt from In Situ Marine Optics.
And I'm Wojtek from In Situ Marine Optics.
Yeah, we just wanted to show you a few of our sensors that we've been designing and manufacturing here for the last 5 years. We've got a number of underwater submersible designs that are specially developed for long-term monitoring. So we have an underwater photosynthetically available radiation PAR sensor. We also have a submersible NTU sensor as well. This is an NTU sensor that's been underwater for about 6 months. This copper faceplate used to look like that colour there. We also have a 3-channel data logger, which devices like these can be plugged into, and it manages the power and it stores data on the SD card. So we started designing these sensors probably about 5 or 6 years ago. We came from an optical oceanography and remote sensing background, and our interests became more in terms of instrumentation and the performance of particular sensors. That with the availability of electronic modules and robotics technologies that were becoming more readily accessible in the market, we decided to take the plunge and make some sensors for ourselves instead of using other people's sensors.
So this sensor here is the IMO. It's a hyperspectral radiometer that measures downwelling irradiance with a cosine diffuser here. It measures the spectrum of light between about 380 nanometers to 950 nanometers at about 10 nanometer resolution. And what we've done with this particular sensor is we've tried to integrate like a lot of ancillary sensors that make processing hyperspectral data a lot easier. For example, this has got an internal GPS. It's got pitch, roll, heading sensor, and temperature, and also water depth. So the idea for these sensors is you can use it as a reference sensor, be it shipborne on top of a shipmast or whatever, collecting continuous downwelling irradiance spectra, or you can use it in a profiling mode where you can profile it in the water up to depths of 300 meters to measure the light levels in the water column. We design our own firmware, and what we try to do is try to make these sensors as easy to use as possible. Having worked with other hyperspectral sensors in the past, it's quite a tedious task to connect them all together, and every different sensor has their own software that you have to use, calibration files that you have to load and what have you. Whereas this, it stores all the calibrations internally, and upon power, you'll just stream serial data, either raw or calibrated outputs, which makes post-processing relatively simple.
And that software design philosophy flows through all of our products as well. We want to make it, well, having used these sensors in the field, we want to make it as easy as possible to collect the data and then post-process and then report on that information. We started developing our own sensors because the price of a lot of the products out there in the market were too expensive, especially for us at a university level. There was no way we could afford a number of these sensors, and for our particular field of research, which is ocean optics and especially remote sensing, you needed a whole package of different sensors, and yeah, if you add up all the price of all of the things to do world-class research, it was just unattainable, and it probably still is unattainable for most universities going along the existing route. route. So we decided to make our own sensors that were affordable using the latest technologies, which means the build costs are quite a lot lower, but the quality of the data is a lot higher than some of these dated analog-based technologies.
Yeah. And another reason, I guess, is that we wanted to make these as simple and intuitive as possible. So a lot of our sensors, basically you apply power to it and you'll stream data out. You don't have to configure, you don't have to give it special commands just to be able to get data out like some other sensors out there. So it's completely easy to use, and also doesn't require that much post-processing because it spits out or streams out calibrated data, and there's less confusion that way. But if you wanted to get into the nitty-gritty and really look into the data layers, it also streams the raw data in the same string. Yeah.